Good afternoon or good evening. I don't know if it's already 4. My name is Tamal Chowdhury. I work with a company called Course 5 Intelligence. We are an AI and analytics company. We've been in business for about 20 years now, 19 or 20 years. One of the things that we do is we partner with a lot of top companies in their research, innovation and R&D labs work, especially with respect to emerging technologies. My presentation today, a lot of what I'm going to talk about essentially is a compilation of the lessons learned from some of those key projects. So what you're going to hear today, a lot of it is actually not just based on today's technologies as we use them, but also in terms of what is currently getting built, what are some of the key prototyping that's happening. And it's not just limited to blockchain, because I am by default an AI guy, but I do head engineering in our organization as well, and that's where IoT and blockchain also comes in. What I'm going to talk about is, as I said, some of the key prototypes that are happening with companies like Google or Microsoft, Lenovo. These are some big names that we work with. And I wouldn't be talking about the individual projects, but really giving you a glimpse of what is going on. So my agenda for today would be to, as I said, give you an idea as to what you can expect in the next 3 to 5 years. But apart from that also, how are these emerging technologies or advanced technologies, as you call them, how are they coming together, and how are they really solving each other's problem areas? That's something we will talk about. Lessons learned by default are something which can get quite boring. So if I bore the hell out of you guys, just raise your hand or do a cross signal or something. I'll understand and I'll move on quickly from that topic. So I hope it's an interesting session for you. Before we start, how many of you, I'm presuming most of you are blockchain professionals or related to blockchain in some way. How many of you are related to IoT, Internet of Things? Okay, one. You guys can see some hands over there. How many of you are related to AI, exposed to artificial intelligence, machine learning? Okay. Fine, so we won't just have blockchain guys. I hope there are others as well. This is an interesting thing that I like doing. Take a 0.1 mm paper, you fold it in, you just fold it and repeat that exercise 103 times. Now don't tell me that I cannot do that because I'm a human being. Imagine a robot doing that. So let's say we take a 0.1 mm paper and we are folding it and we are doing that exercise 103 times. What kind of thickness would you expect? Maybe somebody from the audience, this table? Sorry, one by one. Can you be a bit louder? You go till the moon. Great. Who else? Sorry, loudly. Okay, good. Very informed audience. Who else? Yes. Earth and Moon. So the distance is actually more than 93 billion light years, which is the entire length of the observable universe as we know it today. Universe is expanding, but as of today, it's 93 or 96 billion light years. So it's actually more than that. This is essentially something called combinatorial explosion, which means linear inputs come together and produce nonlinear effects. Taking this idea, we've come across most technologists in the R&D space that we are involved in. We work on something called combinatorial evolution, which means how do we get different sets of technologies to come together, and instead of 2 plus 2 it becomes 22 or 2200 or whatever. That is called combinatorial evolution, and that is essentially what the 4th industrial revolution that we are all witnessing today. I hope all of you are aware of the 1st, 2nd, 3rd and the 4th one today. That's precisely what we are trying to do. Especially people who are in the AI space or space, robots, anything, blockchain, big data, some of the advanced areas, streaming technologies. What we are really trying to do is bring about combinatorial evolution in the 4th, as part of 4th industrial revolution. So with that, I'll start my actual session. The first thing I'll do is I'll look at some of the blockchain's limitations today, some of the limitations of blockchain as a technology, and we'll see how AI and IoT can actually help in when solving some of those problems. Again, as I said, many of these are essentially ideas taken from current research and development and prototyping. So these are not so, this is pretty dynamic. Something might change in the next 2 or 3 months. This is not kind of written in stone, but based on whatever work we've done, my team has done, and this is essentially what we are seeing today. The first problem with blockchain, and don't say it's a problem, don't get me wrong, all the blockchain guys. Anything which is non-cognitive, anything which is not intelligent as a technology or as a solution doesn't have a long-lasting future. That is an AI guy saying. And that's really what we should be aiming for. Whatever technologies come up, how do we enable cognition in them? So, for instance, I'm sure all of you may have heard of 51% attack, right? Blockchain builds consensus, but what if the majority, the guys that are actually building those consensus are actually hacked, right? And they are not telling the truth, they're actually telling the false. So the false becomes the truth. So these are some questions that can be avoided if you are putting in elements of AI to make sure that 51% attack doesn't happen, or any fork issues that we have seen once or twice in the past. Those things are largely avoided through better fraud prevention and things like that. Or any kind of hacking that can be done by coders today. How do you proactively predict that something is likely to happen or going to happen, and thereby take action to stop it? So that essentially is one of the biggest areas of, or one of the biggest gaps of any technology, including blockchain, where AI can actually fill in, AI can actually help. The other problem, and this is a very realistic problem, the database size keeps on increasing. I'll give an example. One of the companies that we work with, I'm sure all of you use their search product every day. It's a very big company. We are doing a prototyping with them for a particular use case. One of the things we've seen is the database just keeps increasing and increasing, leading to a lot of performance pressures. It's not production friendly at all. So I know, there are questions. Can you delete data from a chain? Can you from the ledger? Can you do that? Can you do can you do something else? One of the lessons that we have learned, that we can actually do intelligent data pruning. It's not just you are pruning data based on some rules, but rather it's much more smarter than that. That's again where AI can come in. You can create a mini ledger for production purposes if your main ledger is huge, and that mini ledger is not rules based. It's not because of you thought this is the best way to do it, but rather the system understands on its own. There are neural networks which come into play, which predicts this is how we should be doing it, and thereby they are creating a smart subsystem ledger, which then can be used in production the same way that you would use a master ledger, so without any of the problems that you would see for big databases. The third thing, storing data is not enough. You have to mine them. In this age of data mining, in this age where everybody talks about data harnessing, data capturing, that's really where you need AI and ML to enable data mining there. One of the biggest problems of blockchain, and gradually this is getting resolved, but is still a problem, is about high computing and other usage, energy, electricity, and so on. There are some use cases in blockchain wherein it has been resolved to quite an extent. There are still some areas which is still not resolved. One of the projects that we are doing is trying to figure out if there is a way we can predict what kind of computing resources would be needed, if we can predict that in advance, and accordingly we can plan, and also how do you plan optimization of the resources, optimal utilization of those resources. The other part is most blockchain services are processed in the cloud, whether it's Amazon's blockchain service or Oracle's blockchain service or IBM's. Now every big company has a blockchain service today, or even the smaller startup ones, they have their own services, but largely this is processed in the cloud. So for those of you who are in the IoT field, if I'm talking about manufacturing, that is a big problem today, because my robots, from where I get the data, I need all that data to be put on a blockchain, but they are smaller, I have sensors there, so I cannot use the cloud in real time. I need to go to the microprocessor and microcontroller levels and actually capture data and store data at the same point of time. That is where IoT comes in. You have to do edge computing. For those of you who've heard what edge computing or mist computing is all about, we will have to do all of that, but it's not really possible in terms of cloud computing. So we will have to get to the device level. IoT steps in. Blockchain alone cannot do much. You cannot really use blockchain for a lot of industry 4.0, the industrial Internet of Things, or the factories, or the new factories of tomorrow. You cannot really use blockchain as they are in a production environment again. So these are some limitations of blockchain that I said largely through IoT, AI, and some through IoT you can fulfill. Any questions, anything? I like it to be interactive, so if I get boring again, as I said. Any questions? Sorry, no? Okay. So either I'm too good or I'm too bad. The next part is AI. Now, how do we really use blockchain to solve some of the problems that artificial intelligence faces today? Perhaps the biggest problem with leveraging AI for production purposes is the fact that most of our deep learning algorithms, most of what we do is actually based on neural networks. It's to a great extent a black box, which means you feed data, the models get generated, you have some understanding as to how the models are getting generated, trained, and things like that, but you do not have a clean-cut understanding as to what really is happening. And you're training things, you're training again and again. So for those of you who know how modeling, machine learning, or deep learning, or artificial intelligence models, or even NLP models work, you're feeding data into the neural networks that you've created, data is coming out, but it's only the neural network which knows why it's doing whatever it's doing. And that's happening to a great extent today. As a result of which, the explanation factor is missing. So a lot of companies typically which really need you to tell them why you are taking certain action. If you are building a solution, so if I'm building a solution for, let's say, city, I need to tell them why my AI model has taken that action, which I cannot today. And so because it's finance related, so they would need to know because of compliance reasons or any other reason, but that's not happening today. That's really the biggest challenge in artificial intelligence adoption at this point of time. Blockchains can actually enable that. You can actually have hash functions, and this is something we are prototyping and we are actually working on at this point of time in our organization. So you can actually capture whatever relevant activities are going on within the neural network through these hash functions, and then once you can actually use that data and figure out whether some activities are actually needed or not. You can make whatever improvements is needed. So this is the biggest area where blockchain can tremendously impact AI. And again, as I said, when 2 or 3 technologies like these, when they come together, it has a compounding effect. The effect is really huge. The other problem, and this is more with the regulations that we see today, especially with GDPR coming up, which has just come up in around end May, early June. Blockchain actually offers you an approach through which you can, start adhering to some of the compliance norms as we know them today. And compliance is only going to get more and more severe because the importance of data and the types of data that are getting generated is just so great today. Everybody wants to make sure they are mining the data properly, they know where the data is coming from, where it's going, how it's getting tracked, and all of that. So that really becomes critical. The other thing is, a lot of AI solutions today in the practical world, they are all centralized, and that's because the AI artificial agents are actually running from centralized repositories. That's how things are working. Blockchain, through its decentralization, can actually help to build decentralized AI solutions wherein you're not just dependent on a centralized area. One model fails, you have other models in decentralized environment to come and help you. So these are top 3 areas in the artificial intelligence space that blockchain can actually address. Any questions? Anything? Yes, ma'am. Sorry.
Yeah, actually. Hello, the black box nature of AI,
Right.
how that can be solved with blockchain?
So I'll tell you. So what is really happening is, so let's say I have a convolutional neural network. So a convolutional neural network, for the benefit of you, is essentially used for image, any kind of image processing, computer vision that you use, video processing, any kind of pictorial stuff, you use CNNs or convolutional neural networks. So what we are now doing is, so a CNN, again I'm just going into a bit technical, so there is a pooling layer, there are different layers within a CNN architecture that we have. Now what we have started doing is, we are actually, when we store data on a blockchain, we are actually writing hash functions at a layer level, so that whenever whenever a pooling is happening, let's say some pooling is happening or something is happening, those hash functions actually capturing what exactly is happening, because there is no other way I would know, or my modelers or my scientists would know what really is happening. That's a more technical, we can take it offline, but broadly again we are looking at a layer by layer level. Largely this is employed on the image processing, on the video processing, computer vision side, where you're working on hash functions to see what exactly is being done. The other benefit from that is also, it reduces your, once you've done that for 2 or 3 iterations, it reduces your epoch time or your iteration time for future model building. Yes.
Right, so I like your idea of decrypting the way neural networks work, but I have a question. Why are we using a distributed ledger for that? Why can't we just use a conventional system instead? What is the need of adding blockchain to that again?
Sorry, what was the first part of the question?
So I like the way you're trying to decrypt the way AI works using the hash functions by stepping them up at each level.
Right.
But why do we need a distributed ledger for that? Why can't we just have a conventional system? Because there's no real trust issue here, is there?
The reason I'm talking about distributed ledger in this case is because when we are working on artificial networks, artificial neural networks, one, they have to run on GPUs and not CPUs. So I actually have a lot of them as a batch. Now that is not possible with your, I cannot run, they need a lot of computing power. So I cannot run them on a centralized environment today, on a centralized ledger. That is simply not practical enough for me. That is the reason I have to leverage. Now I can leverage blockchain, or I can, build another decentralized solution and build something which is similar to what blockchain does today. But surely from the fact that it's an ANN, an artificial neural network, because if I run a neural network on CPU, it can run for days and days, but if I run it on a GPU, or I need a GPU, or I need a decentralized environment, the same thing I can get done in maybe 2 hours or 3 hours, especially during the model building process. Any other questions? Okay. Right, so this is where I'm going to talk about IoT and how does blockchain solve some of the limitations of IoT. First of all, today, for those of you who've worked on any kind of industrial Internet of Things products, or in factory products, smart products, security is a big vulnerability today. That's the reason. Whether it's a GE, whether it's a Siemens, whether it's, I'm not sure if any of you are from these companies, they're all facing this critical problem. There's something called mesh computing, wherein all the devices are talking to one another, mesh architecture. So it's not a client server architecture, there's no centralized function, they're all talking to one another. So if I have 5 factories in the globe, all my devices are talking across those factories, how do I know which one to trust and which one not to? And that's really a big problem. It's easily hackable today. So with its cryptography, blockchain actually offers a way to solve that. Has the problem been solved? No, it's just something that we've started looking at, not just in our organization, but globally. We are making small progresses, but this, again, to my mind, will be blockchain's number one gift to IoT if it's able to resolve this problem. The other thing is, most IoT solutions still rely on centralized architectures, and that's how it is. Don't ask me why. Even I couldn't figure that out. It just is. Most of the IoT stuff that have been built in the past 3-4 years, it's largely been centralized in nature, which results in lack of resilience. You would obviously want to counter that, and that's where blockchain comes in. A practical problem of IoT is in terms of intermediaries and high settlement times. I will not go into the details, but again, blockchain because of its inherent nature of bringing down walls, bringing down intermediaries, will be helpful in this particular aspect as well. Finally, IoT is creating a lot of most IoT solutions are creating a lot of data silos today. A lot of the IoT solutions are not really standard products if you look at that way. They are built for a particular company in a very customized way, as a result of which all the devices that are getting generated, let's say for a particular company, even if it's data that can be shared, we are not able to share all of that. It's because of the way the data architecture is, the data models are, how the mappings are done. I mean, there are too many things there. So we are doing a prototype to figure out if we can actually use blockchain databases to capture all of that across companies. So because there's a lot of information, for instance, satellite communication, excuse me. So if ISRO sends a satellite to space, and let's say 5 companies in India, Infosys, HCL, or Tata, anybody, they all want the same kind of data. Now you would actually have to store them and build 5 different solutions. Now instead of doing that, can you just build one uniform solution and you're sharing, because this data is whoever pays you get that data. So things like that. So that is something we are unable to do today, but blockchain, once that comes into effect, once this problem is solved to whatever extent possible, is going to remove a lot of inefficiencies. What I wanted to talk about is how am I doing on time? Okay, I think this is the penultimate slide or so. This is a good example of the 3 technologies coming together. This is something which Fujitsu started last year. So one of the things they're trying to do is, so they have a lot of workers who work in the, during summers, and they get heat strokes, and they have to get the insurance and all of that. So what they have done is, they have sensor devices which detect the heat levels, humidity, temperature, etc. from for all these workers. Then they gather that at real time, and through AI they try and predict, is the person going to get a heat stroke or not, and they take action accordingly. They take remediation actions. Let's assume a worker still gets a heat stroke, has to be hospitalized and all. The moment that happens, automatically the insurance money goes to his bank, and that is because how the smart contract gets triggered, and he doesn't really have to wait. This is a seamless process. So they are experimenting with this. I believe, I am not too sure though, that they are going to turn this into a bigger bigger solution for with a lot of companies involved, but I'm not sure. But again, this is an example of how things can disrupt and transform some of the day-to-day stuff that we are doing. Obviously, there are a lot of issues with convergence today. What I'm talking about is more of a near future, 3 to 5 years thing. First of all, the technical feasibility of many use cases are still being explored. Most of these are in the POC stage, and there is a lot of difference between POC and production. Obviously, there are a lot of scams. I've highlighted some of the blockchain ones, but there are scams in other technologies as well. That really discourages a lot of these top companies from investing and trying to experiment a lot. Then there are ethical questions, and finally, all these are evolving technologies. They have to go through their whole maturity cycle. Things can change. Some new variables might crop up that we wouldn't know. So these are some of the current issues that we have today. Finally, 3 closing comments. This is the future. More than the individual technologies, it's all these technologies coming together that would really impact all of us, business, personal lives, etc. A lot of use cases are being created, but I think this still needs a lot of work in this area. And it's not just AI, IoT, blockchain. There's 3D computing, printing also. There's quantum computing also. I mean, for me, last month my company we started working on something around satellite communication. Excuse me. That, I mean, I've never worked on that before. So that's again something very interesting. How do you know? Space research, all of that, and that's not just for space research for day-to-day, solving day-to-day problems. So it's going to be interesting. That's it. Thank you so much.
Thank you.